We've been working through a mock internal in class, and one of them has got a really complicated reaction. So we're going to go through that very quickly. I'm going to go through the observations and talk you through what we're actually seeing happening here. So the instructions are for us to add aqueous iodide and aqueous, not thiosulfate yet, aqueous copper 2+. So I'm going to do that in a test tube and see what I observe. Potassium iodide is a colourless solution, and I'll use large volumes just so we can see it easily, and copper sulfate is a blue solution. So if I put the two together, I expect to see a pale blue solution if no reaction occurs. But when I do it, it goes yellow. And if I shake it, it starts to go cloudy, which implies that there is a precipitate being formed. Now, it's hard to tell what colour the precipitate is and so on because it's gone this murky brown colour. And I don't know exactly what's happening until I look at my reagents that I'm looking at. Iodide generally becomes iodine, which is a browny, yellowy colour. So I could infer that that's probably iodine. But what it's doing is it's masking anything else that might be in there. And it might be aqueous. It might actually be a brown solution due to this, because iodine probably can dissolve if I've got lots of iodide present. And I do, because I put lots in to start with. So I'm sort of, okay, not sure. It might have flecks of copper in there, because copper can become three things. It can become copper, which is a solid. It can become copper plus ions in solution, or it can become copper iodide, which is a white solid. I'm not sure which one it is in there. It's not this. It can't be this, because that would be dissolved, so I'd not have it cloudy, unless, of course, the cloudiness is due to iodine. So it's a really confusing experiment. So luckily, we were then told to add thiosulfate to it. Now, the nice thing about thiosulfate is that it will react with iodine and remove it completely into a soluble ion called iodide. So that it'll reverse this reaction for us quite nicely. So it gets rid of the colour that's contaminating our result, as it were. So let's see what happens when I do that. And the colour's gone, and I have a white precipitate. I know that iodide is highly soluble, so that's not affecting my result. And even if it was, well, actually, no, it isn't. I know it isn't, okay? Because it's so soluble, okay, in the concentrations we're working in. So now the iodine's gone, thanks to my thiosulfate, okay? That's why the blue arrow, blue reagent. Therefore, I can't see flecks of copper in there, so I can discount that one. I had already discounted this one, which means that it's this. And if I check my little box of reagents and so on that I've had to learn this year, I see that that's a feasible result, because this is a white precipitate. And that's what I see in my test tube. So, the actual redox reaction that we were testing was iodide plus copper and seeing what it makes. And we see that it makes copper iodide, but we weren't sure. So the role of the thiosulfate in this is to remove the iodine so I can confirm which copper product I had. Then I would go on to use Standard Electrode Potentials to further prove this, showing that going to this or going to this would actually have a negative EMF, so it would not be spontaneous, whereas this one would be spontaneous. I then have to make sure I can do half equations for all of the things that did happen. So iodide going to iodine in the presence of copper, which is turned into copper iodide. Okay, so you're going to need to use iodide ions to balance the equation as well. I'll show you that one in just a moment. You also need to show iodine going back to iodide, and thiosulfate, thiosulfate S2O3 to negative, going to S4O6 to negative. I'm just going to do the overall equation before I added this thiosulfate for you, because that's quite a hard one. So what I've got, the iodine one's really easy. 2 I negatives go to I2 plus 2 electrons. And remember, this is the stuff that made it hard to tell what our product was. The copper, we now know is going to copper iodide. That looks really awkward to balance because it doesn't follow any of my rules. There's no oxygen or hydrogen there. All I do, honestly, is I add an iodide ion there. So there's no change to that. Because this is already I negative, albeit in a solid, this is I negative, I'll just add an I negative over here. And then I go, oh, but this one's +1, this side's 0, so I need to add an electron. Okay, so it's one that's a little bit harder to work out. If you get one like that, and you've got another ion attached to it in a solid, just keep that ion in the same oxidation state on the other side. Because only one, this is a half equation, only one thing's allowed to be reduced or oxidized. Only one thing. So it has to be just the copper. The iodide has to stay in a -1 oxidation number. Otherwise, it's not a half equation, it's an incomplete full equation. When I combine the two together, you'll see that I need 2 of this. Okay, so you're going to end up with an overall equation of this. Note that you've got 2 iodides there, 2 iodides there, so it's that. Alright, just do our balancing act, 2 coppers, 2 coppers, 4 iodides, yep, there's 2 there and 2 there, so that's 4. This side has got a charge of 2 times +2 is 4, but then subtract 4 times -1, so 0. Total charge on this side is 0 as well. So I know that I've got this fully balanced.